Hello, College Algebra Golden Bears. Back with you again with a quick video on systems of equations. In our last video, we looked at introducing systems of equations and the first method for solving them, which was substitution. Substitution meant putting one variable in terms of another. Now, the reason we can do that is we have two equations and two unknowns. That is what a system of equations is. It's a set of equations that have the same variables, in this case x and y. So substitution would have looked something like this. If we would have taken equation 2 and rewritten it as x equals 2 plus 2y, we would then know what x is, and we could have plugged that back into our original equation right here for x and rewritten. Now, that works great. You can do that a lot of the time. But we are going to use a different method in this session. We're going to use the elimination method. This one is pretty cool if you have the right setup for it. If the numbers work well, it can be a pretty quick, neat method. You may remember this from your Algebra 1 days. But what we're going to do is look to see if we have any pieces, any terms that if we added these entire equations together, that they would be eliminated, hence the elimination method. So in this case, if you notice, we have positive 2y here, and in equation number 2, we're subtracting 2y. So what we can actually do is add these entire equations together. So if I rewrite them like this, and then x minus 2y equals 2, we can do some old school addition right here. And just add these straight up, adding the like terms. Bring down our equal sign. If we add the x terms together, we'll get 4x. And notice what happens when we add the y terms. 2y plus negative 2y will be 0. So that term is eliminated. And all that will equal 16. So we end up with a very simple equation. 4x equals 16, and x equals 4. Now, if you remember from the last section on systems of equations, once we find x, we're not done. We need to also find y. So we need to plug x back in to either equation, it doesn't matter, and we'll get y. So let's take the equation number 2. We'll plug in x in equation number 2. So equation number 2 was x minus 2y equals 2. So now that we know that x is 4, we'll just make that 4. So 4 minus 2y equals 2. We'll work our algebra. We'll get negative 2y equals negative 2, and y equals 1. Now that we know our solution set, x and y, we write that as a coordinate point, 4, 1. So there you go, there's the elimination method. Now, that is a very simple application of it. Let's try it with something like this. 3x plus 4y equals 14, and 2x plus y equals 1. Now, if you look at these right away, you recognize there aren't any opposites. But there could be. We can adjust the terms to get opposites if we take an equation and multiply it through. What I mean is this. We have 4y here. What would be the opposite of 4y? Well, if we could have somehow negative 4y in this equation, equation 2, we would be able to add those two equations and eliminate. Well, if I take negative 4 and multiply this entire equation by negative 4, whoops, where's my pen? Multiply that entire equation by negative 4, we'll have an entirely new equation. It'll now look like this. Negative 8x minus 4y equals negative 4. All right, now if I add that to our original, plus 3x plus 4y equals 14, we'll have a new equation, and we will have eliminated y as a variable. So our new equation will look like this. Negative 5x plus 0, because y is eliminated, and that will equal 10. So we have negative 5x equals 10, and x equals negative 2. Now remember, we're not done. We need to now plug x back into either one of these equations in order to find y. So I'll take equation number 2, and we'll say 2 times -2 plus y equals 1. So -4 plus y equals 1. We'll add 4 to both sides, and y equals 5. You notice this is actually one of the same examples we did in the substitution video, but we did it with elimination. So there's an example of choosing 2 different methods. You'll have the choice of either one. All right, so our end result here will be -2, 5. So those are 2 great examples of how to use elimination. If you can't use elimination right off the bat, you can adjust your equations by multiplying one or both of them by coefficients that change them in order to eliminate. All right, so what did we just do there? Well, the first step is to adjust the equations. Adjust the coefficients. That allows us to find opposites when we add. So after you've adjusted the coefficients so that you have opposites, you can add the equations together. And when you add the equations, you will end up eliminating one of the variables. So when you add, you're able to solve for one, but remember, we're not done. We need to plug that back in. So in the end, we plug in x, and really, or y, depends on which one we solve for. We plug in x or y. So if we plug in x, we do that to find y. To find y, or x, if we solve it the other way around. And remember, our solution is a point. X comma y is our solution. All right, there you have it, elimination method. You should be all set up for the homework, and we'll see you in class. Go Team USA!